Here I've drawn a parallelogram with its two diagonals. We want to prove that the diagonals bisect or half each other. In other words, we want to prove that this distance m equals this distance n, and that the distance k here equals L. I can show you the values here to show that if indeed we've drawn a parallelogram, the diagonals do bisect each other. And I have this shape set up so that whenever I move it around, it's always a parallelogram. And you can see that m is equal to n and k is equal to L. Anyway, let's prove this. Now, I've marked in angles A and B here. Angles A and B are called alternate angles, as we've seen before. Alternate angles are equal. So alternate angles are got when a line cuts across two parallel lines. So these two angles are called alternate angles, or Z angles, because we have the Z shape formed. C equals D, these are called opposite angles when two lines cross. So now, if we look at triangles 1 and 2, we see that the angles are the same in both of them. So this is triangle 1 and this is triangle 2. If two angles are the same in two triangles, then the third angle is automatically the same. So this angle here must equal this angle here, because the three angles add up to 180 degrees. So the two triangles are actually similar. Another way to show that these two are the same is, of course, by noting that they're alternate angles. Now, what else do we know about these two triangles? Well, this side is equal to this side of the second triangle, because C and D are opposite sides of a parallelogram, and opposite sides of a parallelogram are equal. So we have the case that two angles and a side are the same in both of these triangles. That's one of the conditions for congruent triangles. That condition is abbreviated ASA. So the two A's refer to two angles the same, and the S refers to a side that's the same. So we've got that one side is the same, C and D. So these two triangles are congruent, so they're equal in every way. So that means that the other sides are the same. So let's see what the corresponding sides of these two triangles are. Well, we can see that M and N are a pair of corresponding sides. N is opposite angle A, M is opposite angle B. So both N and M are opposite angles that have the same value. So that means that M and N must be equal to each other. Next we can look at another pair of corresponding sides. That's the side opposite this angle here, which I'm calling dot. Sides of length K and L are corresponding, and they must be equal to each other in these two congruent triangles.